Hello, my name is Muhammad Nakib Hakimi bin Akmal, B0319104007. I'm from BITI S1G2.
Assalamualaikum warahmatullahi wabarakatuh. I'm Ahmad Shazali Ali from S1G2.
Assalamu alaikum. Hello everyone, my name is Muhammad Rida from group BITI S1G2.
Assalamualaikum and hi everybody. I'm Muhammad Amri Shafiq bin Zulkifli from S1G2 BITI with metric number B0319100016, and we all will present to you the database project entitled Gym Management System.
Assalamualaikum warahmatullahi wabarakatuh and good morning. My name is Muhammad Nakib Hakimi bin Ahmad. So, today we will presenting about our database project BITP 1323. So, the topic that we chose is Gym Management System. As we all know, gym is a place where everyone can exercise to get much healthier, to lose weight and much more. It is a place where everyone can do safe and tension-free live physical exercise. People can do everything in the gym, like doing exercises to get much more healthier and to lose weight, of course. But first, we want to know how the owner of a gym runs the management system. The gym management requires a system that handles all the required and minute information according to the ease and proper protection of the database. Right here. Database. So, we decided to make a software that stores all information that take place at the gym. So, the main objective of this management system is to design and develop a user-friendly system to make an efficient computerized gym management system, to make an accurate system without any data redundancy, to secure data storage for authority end, to secure the user end's data by providing each user's own personal credentials, to make a flexible system which can maneuver the customer-staff relationship in an effective manner. Next, to provide better graphical user interface. And the last one is to make a computerization can be helpful as means of saving time and money.
Okay, here we go to the entity relationship diagram. An ER model is typically implemented as a database. In a simple relational database implementation, each row of a table represents one instance of an entity type, and each field in a table represents an attribute type. In a relational database, a relationship between entities is implemented by storing the primary key of one entity as a pointer or foreign key in the table of another entity. Here is our ERD. We have three tables here, which are branch, member and also staff. We go to the first table first, which is branch. We got the primary key here is branch ID. We also have branch street, branch city, branch postcode and also branch phone number as other attribute, and here staff ID as a foreign key, which is referred to the table staff. We go to the table staff. We got staff ID as a primary key and also four other attributes, which are staff name, staff address, staff position and also staff salary. We go to the third table, which is member. We got member ID as a primary key and also member name, member phone number, member address, member type subscription, member payment status, member account, member BMI, and also we got here two foreign key, which are staff ID, which is referred to the table staff, and also branch ID referred to the branch table. Here we got business rule for our ERD. First, a staff can train many members. A member can be trained by one and only one staff. So we see here, the staff can train many members. we got the relationship here is one to many, and also a member can be trained by one and only one staff. So we got here one to one relationship. Second, a branch has many staff, and also one staff can manage or work at one and only one branch. You see here, a branch can has many staff, and one staff can manage or work at one and only one branch. So we got here one to many relationship, and here one and one relationship. We go to the third business rule, which is one branch can register many members, and also one member can be registered at one and only one branch. We see here one branch can register many member, which is one to many relationship, and also one member can be registered at one and only one branch, which is one to one relationship. Okay, next we go to the data dictionary. Okay, here we got one table for table branch, and we got attribute name, content, data type and size, format, range required, default value, unique, PK or FK, and FK reference table. So here is our attribute name, such as ERD, branch ID, branch street, branch city, branch postcode, branch phone number, and also staff ID. The content for branch ID is branch identification number, the branch street, branch city, branch postcode, branch phone number, and also the staff identification number. So the data type for branch ID, we put it as VACHA2, and the size is 13. The branch street is VACHA2, the size is 100, because we don't know how long the name of street. The third one is branch city, VACHA2, and the size is 100. The branch postcode we put as integer, and the size is 7. The branch phone number is VACHA2, and the size is 13. And also the staff ID is VACHA2, and the size is 13. So branch ID is a primary key for this table, the table branch, and also the FK for this table is staff ID, which refers to the staff table. We go to the next table, which is table member. We got here some attribute name, which are member ID, member name, member phone number, member address, member type subscription, member payment status, member account number, and member BMI. And also we got here staff ID and also branch ID. So the content for the member ID is member identification number, and here member name, member phone number, member address, member type of subscription, member payment status, member account, member BMI, and staff ID, and also branch ID. So the data type and size for member ID is VACHA2, and the size is 11. For member name, VACHA2, and the size is 20. For member phone number is, we put here integer or number, and the size is 11. For member address, we put here VACHA2, and the size is 100. Member type subscription, VACHA2, and the size is 20. Member payment status, we put here VACHA2, and the size is 10. Member account number, we put here number or integer with the size of 20. For member BMI, we put here VACHA2, and the size of 5. And staff ID, same as table before, VACHA2 and the size of 13. Branch ID, VACHA2 and the size of 13. And here for this table, the primary key for this table is member ID, and also the foreign key for this table is staff ID and branch ID, which staff ID refer to the table staff, and branch ID refer to the table branch. So we go to the next table, which is staff. And the attribute name for staff is staff ID, staff name, staff address, staff position, and also staff salary. So the content for the staff ID is like usual, staff identification number, staff name, staff address, staff position, and also staff salary. And The data type for staff ID is bacha2 and the size is 13. For the staff name, we put here data type is bacha2 and the size is also 13. For staff address, we put bacha2 and the size 100. For staff position, we put bacha2 and the size 20. And the salary, we put here integer or number and the size of it is 5. So for this table, the primary key is staff ID.
And now I will be presenting about the DDL statement. DDL stands for Data Definition Language, and you can see here this is the language for each table, and I will show each table and the data inside. And you can see here this is the first table is table staff. You can see here is the inside the data there is staff ID, staff name, staff address, staff position, staff salary number, and the primary key is staff ID. And you can see in front of the data is the type of the data and how many characters are allowed to be in each type. And below there you can see all the data inside the table staff. And here is the table after the data have been entered. After that you can see the table branch. You can see also all the data that inside the table and the data type also. And here is all the data that inside table branch. There is the data after the branch after it's inside the table. And the last one is table number. You can see here all the data inside the table number and what's inside, the rest of the data. And here is the data after it's been in a table. And now I will be presenting about the DML statement. DML is data manipulation language. Is how you can change in the table or view data in the table. And here you can see display the member address and member ID. When we write that, we can show here the table display this too. And here when we want to display member ID and member BMI, we can see display it also. And here also. And here we show the member ID, the member name and member phone number. You can see we can display all of them. And here to retrieve the member name and member address, you can see we can retrieve them. Here also to find the minimum, maximum and average staff salary, to count how many overweight members, and to list members' name and branches cities based on brand ID. And here you can see also show members that has the highest BMI, and also to count that haven't paid yet. And here to display member information with the member ID, and to list the branch ID where there is either a member or a branch. And here to find the number of members in each branch, and here to display the member information in branch BR002.